Hello, best and VFS class. You're welcome to yet another chapter or topic, and that is probability and counting rules. So, we shall start by defining probability, and this is simply a chance of an event happening. And for an event to happen, you must do something. So, what we do in order to get an outcome is what we call a probability experiment. So it is that process that leads you to an outcome. For example, if I want to find the probability of of getting ahead of getting ahead on a coin, what I'm supposed to toss. So tossing becomes the experiment. So the probability experiment is that process that leads you to a well-defined outcome. And now, when we carry out a probability experiment, we have what we call outcomes of all possible outcomes. And the summation of all those possible outcomes is what we call a sample space. For example, I've given an example of tossing a die. Tossing a coin. A coin has a head and a tail. So meaning if I toss a coin, I expect to get either a head or a tail. So meaning there I have two outcomes. So my sample space is 2. If I roll a die has 6 faces. So meaning the sample space for that particular case will be 6. So I expect a total of 6 outcomes. So, and that leads us to the formula of probability, where and it is noted by number of outcomes over the total number of outcomes in the sample space, or over the sample space. For example, if we use a die, if I roll a die and, for example, and get the probability of getting a 2, I can only get 1 2 when I roll once a die. So therefore my probability will be 2 over that sample space. Now sample space are all those possible outcomes, the summation of all possible outcomes, meaning my probability will be 1 out of 6. And in case it is a coin, my probability of either getting a head will be 1 over 2. So that is basically probability. And please note that a probability can only be expressed as a fraction, a decimal, or a percentage. A fraction meaning that the maximum probability we can get is a 1. If you're very certain and you're sure, for example, if you toss a die and you're sure, if you toss a coin and you're sure of a head, then the probability will be 1. If there is no chance of getting a head, the probability will be 0. So the maximum probability you can get is a 1. So that leads us to probability rules. And the first rule emphasizes what I've just mentioned, that the probability can only be greater or equal to 0 or less or equal to 1. So it lies within 0 and 1. So in case you do your calculations and you get a probability that is greater than 1, just know you're wrong. However, you could express this as either a fraction or a percentage. So still this emphasizes what I've said, that if an event cannot occur, its probability will be 0. And if you're very certain of your outcome, then the probability will be 1. So still the summation of all probabilities in an outcome is a 1. So now we are going to look at the different rules that guide probability. So the first one is the addition rule, and we are going to look at a scenario where events are mutually exclusive. Mutually exclusive events are those events that cannot occur or happen at the same time. So for example, if I want to get a probability of getting a Thursday or a Friday in a week, there is no single time, unless maybe God changes our calendar and timelines, there is no single time you're going to get a Thursday and a Friday. So a Thursday and a Friday are mutually exclusive. They cannot happen at the same time. So therefore, if I'm interested in getting the probability of either getting a Thursday or Friday, the probability will be the probability of getting a Thursday plus the probability of getting a Friday. So the probability of A or B will be probability of A plus probability of B. Then an example on that, for example, if you're interested in finding a day of the week, in case a day of the week is selected at random, find the probability that it is a weekend day. We all know that we have 2 weekend days in a week. That is a Saturday and Sunday. So therefore, the probability of getting either Saturday or Sunday will be the probability of Saturday. And remember, from our formula for probability, the probability of Saturday will be the probability of that day over the sample space. Now our sample space here, a week has 7 days. So we shall get a Saturday can only appear once in a week. So therefore we shall have 1 out of 7. So likewise, we can only have 1 Sunday. So the probability of getting a Sunday will be 1 out of our sample space over 7. But now remember, to get the probability of a weekend of either Friday or Saturday, we add the 2 probabilities, which gives us a 2 out of 7. So that is our first section of the addition rule. Then the second rule or part of addition works when the events are not mutually exclusive, meaning if the events can both happen on the at the same time. So therefore, getting a probability of B or A will be the individual summation of the individual probabilities, but then we subtract a situation where both of the activities happen at the same time, because we are only interested in getting a probability of either A or B. So we subtract that situation where they both happen. For example, if I'm interested in getting a probability, if I have a probability of someone being in base 2 and a probability of someone doing agriculture, but then I also have a probability that that person I'm looking at is a university student, and probably I'm looking at 2 universities, maybe a UCU and Makerere student. So if I'm only interested in getting a probability of an agriculture student and a student of Makerere, so I will have to subtract the probability when a student is both from UCU and both doing agriculture. So there we subtract the intersection, or that particular scenario when both of them happen at the same time. And we see that this still works in the first example. However, the intersection is always a 0, because these two, when they are mutually exclusive, they cannot happen at the same time. Then the other one is what we call the complementary rule. So a complementary rule, from our P4 mathematics, a complement of a set. So a complement of a set are those outcomes that are not included in the set. For example, if I want to get the probability of A complement, the probability of A complement, remember that total probability is always a 1. So therefore, the probability of A complement will be 1 minus probability of A, which is here. Sorry, this doesn't have to have the bar up. It is 1 minus probability of S. I'm going to correct it in the notes I uploaded. So a complement is the total probability minus the probability. So that means that if I add a probability plus its complement, I should get a 1, because the total probability is 1. So we have an example here that this is supposed to be the probability that find the beans will germinate is 1 out of 5. Find the probability that beans will not germinate. So beans not germinating is the complement of beans germinating. So therefore, that if I have the probability of beans germinating, to get the probability of beans not germinating, I'll get 1, which is my total probability, minus 1 out of 5. So that will give me 4 out of 5. Then the other rule is what we call the multiplicative rule, and this still is used in two scenarios. The first scenario is when the events are independent. So when the events are independent, independence means that occurrence of one event does not affect occurrence of the other event. If we take it to if we relate that to the um, independence of a country, when you get independence, you get the freedom to make decisions. So what happens in one country if you were formerly colonized, what happens, or the decisions you make as a country are not influenced by what is happening in the other countries. So that is the same in probability. So when events are independent, an activity occurring does not influence the occurrence or not occurrence of the other activity. So therefore the probability of B and A will be probability of A times probability of B. So we have an example that if a coin is tossed and a die is rolled, these are purely independent. Tossing a coin has no influence on rolling a die. So the probability of getting a tail on a coin and a 5 on a die would be the probability of getting a tail. Remember, when you toss a coin, there are two possible outcomes, and there is always one tail, so it will be 1 out of 2. And then a 5 on a die, there is also only one 5, and then the sample space is 6. So the probability of getting a tail and a 5 will be 1 out of 2 times 1 out of 6. So then the second scenario when the multiplicative rule is used is when the outcomes are dependent on one another, or the events are independent. In dependency means that one activity depends on the other, or for one activity to happen, one must have happened. So therefore the probability of getting A and B will be the probability of A given times the probability of A given that B happened. So this is probability, it means that B happened given that A happened first. So that leads us, so from the multiplicative rule of dependent events, we can go to conditional probability. So what we have here is what we call a conditional probability, the probability of A or probability of B given that A happened first. So to get the conditional probability, we just make this the subject of the formula. So conditional probability of an event means that an event happened because another event happened first. So the conditional probability of an event can be got by from the formula from multiplicative rule of dependent events, which was this. So we simply make A or A given B given that A happened first the subject of the formula, and there we shall be able to calculate the conditional probability. Then we have what we call a binomial probability distribution, and a binomial probability distribution basically looks at experiments that are classified as either successes or failures. In other words, a binomial experiment always has two outcomes. So it is either a yes or no, or either a success or a failure. So any probability that has only those two options is what we call a binomial probability distribution. So these are some of the requirements. So each trial can only have two outcomes, or it can be reduced to two outcomes, that is to either yes or no, or to either success or failure. And the number of trials should be fixed and known, and then the outcome of each trial must be independent of the other, or outcome shouldn't influence of one outcome shouldn't influence the outcome of the other event. And then the probability of a success must remain the same, for each trial. So this is the formula for the probability, for binomial probability distribution. N is always the total number of outcomes or elements. X represents the successes, and then P represents the probability of success, and Q represents the complement or the probability of failure. Remember, complement is what is not in this set. So if our success is P, the complement will be Q. Or if our success is P, then the failure will be Q. So when we want to calculate a binomial probability distribution, we shall be using this formula. So, and then we can also get the mean, variance, and standard deviation. So the mean is NP, where P is the probability of success, and N is the total number of elements or outcomes. Then variance is given by NPQ, where N is the total number of elements, P is the probability of success, and Q is the probability of failure. And then the standard deviation from our previous lecture, we saw that standard deviation is the square root of variance. So when we get the square root of that, we get the standard deviation. So an example on that, a survey showed that 30% of teenage consumers receive their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that at least 3 of them will have part-time jobs. So we are interested in getting the probability that at least 3 of them. So meaning they want 3 and above. If the question was find the probability that 3 of them will have part-time jobs, then we could only stop at 3. But now they want at least 3, meaning they want 3 and above. But our maximum number of teenagers was 5, so we shall get the probability when 3 of them get their money from part-time jobs, when 4 and when 5, and at the end we shall add the different individual probabilities. But now in the same statement, they have expressed to us that it showed that 30% of the teenage consumers receive their spending money from part-time jobs, meaning our probability of success is 30% or 0.3 if I'm to express it in as a decimal. So meaning our P is going to be 0.3. And remember, Q is the failure. So if the success is 30 or 0.3, the failure is going to be 0.7 or 70%. The complement, remember, the maximum probability is 1 or 100%. So if I have my success at 30, the balance to make 100 will be my failure. So 30, the balance to 100 is 70, or the balance to 1 is 0.7 as a fraction. So therefore, we get the individual probabilities. So I'm going to start with when x is 3. So x is that element of interest. So when x is 3, remember our n is 5, our x is 3. So these are factorial signs. So in your calculators, you should be able to, or 3, what this sign means, I'm going to multiply 3 by the digits below 3. So meaning 3 factorial will mean getting 3 times 2 times 1. Then 4 factorial will be 4 times 3 times 2 times 1. 5 factorial will be 5 times 4 times 3 times 2 times 1. Otherwise, you can easily still get this on a calculator. When you use a scientific calculator, there is a button that has this exclamation mark, which means factorial. And remember, our board mass, when we have anything in the bracket, we first deal with what is in the bracket. So we're going to first subtract 3 from 5, get a 2, so get 2 factorial times 3 factorial. So here we shall have 1 factorial times 4 factorial, then 0 factorial times 5 factorial. Then multiply. So this is 3 to power 0.3 to power 3 and 0.7 to power 2. So what you get will be the probability when 3 people get their money from part-time jobs, then 4. So since the question was saying at least 3, so we are going to add 3 plus 4 plus 5. So the total we get will be the probability that at least 3 or 3 people and more receive their money from part-time jobs. And that's it. Thank you so much. Please stay safe.